Hey guys, Sally and Derek Tungmola here. We are the owners of Auto Rehab. We've owned our own shop for 7 years and Derek has been in the automotive industry for 15 plus years. If you're a performance guru, you're really going to want to watch this video because we're actually showing you how to put in a piston, how to fix piston gaps, and also how to compress piston rings. So you're going to want to watch this video. So Derek, take it away.
Hey, welcome back guys. So today we have a small update on the Supra. We're putting the motor together. We got rings and bearings and some things that we needed to go back together. We had finished tearing it down and found that there was a used oil pump on this motor. Now, oil pressure is one of the key components to an engine staying alive, especially a performance engine. Did not understand why there was a used oil pump on. Obviously, we have a powerhouse racing, high volume oil pump coming. But in the meantime, for the engine assembly, we have these. I know we've shown them before. There's Titan Motorsports forged pistons. These are their heavy duty race pistons. We have the upgraded wrist pins, which are thicker walled to handle all the pressure that's going to be on top of them. And of course, these are the Carrillo rods. This whole setup is capable of withstanding a lot of horsepower and torque. Today, we're going to show you about ring gap. This is the distance between the piston rings. When they're in the cylinder and closed, there's a gap right here. So, for starters, there's a difference between the two rings. We have a top ring and a lower ring. And if you look here, there's this little indication. There's an N, a little logo on here, and there'll be one on each ring. That faces towards the top. Oftentimes people don't know the orientation of rings. When we took this motor apart, one of the rings was upside down. The second ring was upside down. It has a beveled edge designed to help clean the cylinder wall of oil on its way down. When it's upside down, it'll build up and it can get around it, and that causes blow-by and problems down the road. So there's a math equation in multiplying your bore by 50 thousandths to get your top ring gap and your second ring gap. We came to a total of 0.017 for the top ring and 0.19 for the bottom. So we are going to place this ring into the cylinder. We're going to set it in here. We're going to use the piston to push it down even. So we use the piston to push the ring down so that it's evenly sitting in the hole. Once we get that, we're able to measure the actual ring gap. When you look inside this hole, there's a gap right here, and this is your end gap. We put a 17 thousandths feeler gauge and we're unable to get it in. So this ring needs to be cut or filed to accommodate the expansion that's going to happen when we use high boost and nitrous. So we remove this ring, bring it over here to a ring file. A ring file, you always place the ring the way it sits in the motor, facing up. You put light pressure, try to keep it as circular as possible, and then just light motions. So we gave it a little bit. It's better to go back and forth multiple times versus cutting too much off. We're going to set it back in the hole, and we're going to use the piston again and measure it one more time to see if we found the right gap. Again, we take this 17 thousandths feeler gauge, place it in here, and it's starting to go in, but it won't go all the way down to the cylinder wall, so we still have to trim some more off of it. So we'll pull it out.
We have a nice even contact.
And then we're going to try measuring one more time. This process you want to spend a lot of time on. Be very careful and go slow, take your time, just to make sure it's correct. And if you go too much, the best source is to buy another set of rings and potentially start over. So see, that just went in all the way. That top ring is now filed to the correct gap that we need. Now that this is done, we'll place it here and we'll do the same thing to the second ring. This second ring is made out of a different material. It cuts much faster, and so less turns per time that you check it. But for starters, we're gonna check what it is before we file anything. And this ring set that you file is for just this cylinder, not any others. And so don't mix them back and forth. Do the rings per cylinder. The second ring gap is supposed to be the 19 thousandths. So, surprisingly, from factory, that one is the right size. So that one does not need to be filed. So we can pull that back out. This set of rings is ready to be put onto the piston. Now, when setting your rings, this is where it's important that you pay attention to the top. The little symbol there signifies that that goes towards the top. And that beveled edge will be in the correct position. When setting rings, these can very easily break if spread too far. So we just put a little pressure, enough to get on around. And that ring is in place. Now, we'll take this next ring, identify the direction it's supposed to go. I'm gonna flip the piston. This is where our gap is on this side. I'm gonna flip it 180 degrees and put it on the opposite side. You don't want your ring gaps to end on the same position. You want them to all end in different positions, and that allows it to seal properly. If they line up together, so this ring gap is here, and this ring gap is here. So they're opposite of each other. On Subaru engines, where the piston sits down, because of gravity, oil will want to sit in the bottom. We would put the gap up here and up here at those two positions. Before we put this in, we will heavily lubricate it. We have some synthetic 540 here. We fill the oil ring, the ringland, with oil. Trying to get as much on there as possible. There's no such thing as too much at this stage. And then we're also going to cover the skirt because we want it to go in smoothly. So a lot of oil. And then here is the ring compressor. I put oil in here, lap it around. When you're putting this in, make sure your ring gaps are in the right place. You set it inside. We tighten this. And this will compress all those rings so they're ready to go into the hole. So that just compressed it all. Before we go in, there's two things we need to do. One, we need to oil the top of this cylinder wall. So we put a liberal amount of oil up here. And secondly, because this bearing is gonna make contact with the crankshaft, we use assembly lube to lubricate it. So we put a nice little layer of assembly lube. This allows for the first time on a dry startup, before you have all your oil pressure, that the parts are lubricated and stay lubricated so there's no metal to metal contact. We don't want to pre-wear the motor out. So we lubricate the bearings, both sides, and this is a very important part also. The rod bolts need lubrication at the top where they make contact with the rod, or with the cap, and on the threads. Both of those are important because you don't get the right torque unless they're able to move freely. Metal on metal contact can potentially slow it and cause it to have an inaccurate torque. So having those lubricated and ready to go is important. Now, when setting the piston, it is very important to know what direction is the front. The way we set our pistons up, this Carrillo marking is going to face the front of the engine, and that allows for the valve release to be correct for intake and exhaust. Now we're going to set this down carefully without hitting any of the sidewalls. We align it correctly. We use this to line up the ring compressor even.
Very professional technique.
It is. And then to not damage the piston, I'm going to put a rag in here. We hold the ring compressor against the cylinder and we can push and hammer it in with the bottom of a hammer. So this is why we protect the piston. Now that that has gone in, rings are seated, everything's correct. Now we have to slide the piston down till it makes contact with the crankshaft.
We're going to spin the engine.
That thing is a beast.
We line up the rod and slowly push the piston in until it makes contact. As you can see, we lubricated the crank. We're gonna take our bearing cap. One thing you'll notice, the notch for the bearing to hold it in place, both notches go on the same side. You don't want to flip the cap around. So make sure they line up correctly. We're going to put our lubricated bolts in, rotate them, tighten them, and then we're going to torque this. According to these particular rod bolts, these Crillo rods came with car bolts. These are designed to take 58 foot-pounds of torque. So we are going to torque them, and every time you torque a motor, or like a bearing cap or a rod cap, you always want to rotate the engine afterwards to be sure it still rotates. If it gets hard when you tighten something, that means that bearing clearance is wrong or something along those lines is wrong. So being sure that you're aware of how it feels as you're assembling the motor. So I'm gonna get that just kind of tightened up, get this one kind of tightened up, and then I'm gonna go for the torque. So typically they want torque to be a sweeping motion until it clicks, right there. And here we want to go sweeping motion until it clicks. I always double check these just to be sure it's the same. And now the part that I had mentioned, making sure that the motor rotates and that everything works like it's supposed to.
So, when we flip this engine over,
as you can see, there's the piston we put in. We typically use like a lint-free cloth to try to clean up anything that's excess. And being that we're not gonna put the head on yet, we're gonna bag this motor up so that dust and contaminants don't get into it. And when the head comes, we'll be ready.